I get this question a lot when I'm out in the field. You know, what would my CPM look like in Flowline? How do I turn my CPM into Flowline? A lot of times this comes from the pre-construction side, where there's some interest in having kind of a peer review of the data prior to, let's say, baseline approval, or before submitting the baseline to an owner. And that's a great way to kind of give another look from a different perspective on your dates and durations, and also to get a quick resource load and quantity load on the data as well as a secondary analysis. I also get this request a lot and this question a lot from those of you who have already started using Schedule Planner and are looking for ways to get started with implementation on an actual project. Typically, the first step is to mimic what you have in a CPM schedule and use the tools available in the Flowline interface as a way to analyze that and continue the analysis and the development of the schedule throughout the process. Now, oftentimes this is done in a parallel effort to the CPM schedule, and I think that's where you can start to compare and contrast the methodologies, and also to understand, what kind of data is required to support each, and what kind of value you can get out of it. So let's go ahead and go through the basic process of the CPM match first, and then we'll talk a little bit about how we can use the tools available in Schedule Planner for analysis, reporting, and then carrying that over once you go through the analysis and implement some of the suggestions for optimization, carrying that over into the optimization for the rest of the schedule. And of course, after developing all that data, you'll definitely want to use it for production control. So immediately after that first question, the following question is, what do you need from me, or what do I need from my team in order to get this process started? There are several levels of detail that you can go into with the CPM match. You could simply represent the Gantt chart as flow lines without any resource or quantity loading, and you could simply use the graphical user interface to identify areas of discontinuous work or gaps and bottlenecks in the schedule. However, there's much more value to be had if you can utilize any existing models that you may have for the job. Of course, we can use the 3D models for visualizing the work and also planning the locations so that we have a balanced, quantity-wise balance and geometry in the workflow in the schedule. It's very helpful, but not necessary, to get a logic export from whatever CPM software you're using. I usually ask for this one first. It helps to expedite the process. So for those users out there who are thinking of doing this process at home or in the office, try to get some logic out of the source software that the CPM is starting with. And then ultimately, as is the goal with our typical optimization process, and certainly in this case as well, is to input as accurate as possible production data to represent the expected crew sizes and productivity of the resources that you're going to be using and dedicating to your activities in your schedule. A lot of times that's the toughest bit of information to get. On our side, when we provide this service to our clients, we usually refer to the Vico standard database, which has a lot of historical data from projects that we've worked on, and industry standard data that gives us a real good idea of what type of productivity rates and typical crew sizes for the individual tasks. So once you input this data in, you go through the CPM match process. What can you expect out? Our standard deliverables are a CPM match schedule planner file. So that'll be the replication of your CPM schedule in Flowline. We'll also provide an analysis report of the CPM schedule using the various tools that are available in the Flowline interface. As a third deliverable, we will run a first-pass optimization on the CPM schedule, since we will typically have a resource and quantity-loaded schedule, taking that information from the 3D model and from production data that could either be a standard or gathered from our clients. We can use, following typical location-based management theory, to optimize the crew flow, eliminate starts and stops, balance resources, etc., and provide a draft-optimized schedule that we could then carry over into some validation workshops where we will come to your office or come to the job site, work through the, we'll first review the CPM match and then work through the optimized version with you and your subcontractors to validate the data and to hopefully get some sign-off and approval and rollout. So let's talk a little bit about how the process works technically. One question that I usually get related to this process is, can't we just import a CPM schedule into Schedule Planner? The short answer is no, but allow me to qualify that. The differences between the CPM schedule and the Schedule Planner file, or the Flowline schedule, we like to characterize, or let's say if we want to classify these two schedule methodologies, the Gantt chart schedule would be activity-based, whereas the Flowline schedule would be location-based. What this means is when you are representing an activity, let's say hanging drywall, in a Gantt chart type schedule, you are going to generate a unique activity for each location that this task will occur. That activity will have a unique ID, and it will have a unique set of logic to all of the other activities that it has relationships with. In the Flowline schedule, however, we would represent the hanging drywall task as what we call a uniform task, which is one single activity that's projected through all of the locations that it is active on. And this presents some difficulty for importing the data in the Schedule Planner because the alignment between the two, let's say 10 activities into one, requires both a location management and logic management process. And in this case, as our best practice for turning a CPM schedule into Flowline on the Vico side, we have defined a more of a manual process for converting that information. It's a little bit faster than it would be if you tried to figure out a translation. And ultimately, it allows you to QA the data in much finer detail than you would if you were to simply import that information. And so, as with modeling your own construction model, getting into the details and restructuring something from scratch often gives you the best chance for QA and picking up anything which may have been omitted in the original phase. So if we're talking about using a CPM schedule, certainly from our side, we've never seen it before when we get that information from the client. There's some information that we try to pull out first in order to structure the Flowline schedule. As I mentioned before, in the comparison between a Gantt chart and a location-based schedule, one of the primary differences is the way that locations are represented. So the first thing that we try to, one of the first things that we try to pick out of the baseline schedule is the location breakdown structure, or work breakdown structure. We also are looking to identify individual schedule phases. Oftentimes those are in alignment. Each schedule phase, for example, substructure, superstructure, exterior, interior, often has a unique location breakdown structure that results in a different installation sequence from task group to task group. And so that, in a location-based management system, and certainly in the Flowline system, that's the foundation data. That's one of the fundamental organizational structures in Schedule Planner. And so we look to pull that out Typically, that information is identified in let's say a Primavera schedule as the headers, as you can see indicated in the images on this screenshot. Now, as part of our own internal process, we usually take this information and start to dissect it from the CPM schedule and plug it back into a spreadsheet that lays everything out nice and neat for us to copy and paste basically back into the schedule planner format. Now, when we review or try to pull out the location breakdown structure from the CPM schedule, we're not only simply copying the data, but we're also QAing that data at the same time. When we identify what is a unique location in the CPM schedule, we definitely want to represent that with the same kind of breakdown in Vico Office and in Schedule Planner. The goal, of course, for the CPM match is to replicate as closely as possible the CPM schedule so that we can provide analysis in the same format as what you may have seen already in the CPM schedule. So we do replicate that location breakdown structure as accurately as possible. The big difference, of course, with the Vico Office workflow is that we're going to be using a model to help define our geometry. And for those of you who are familiar with the Vico Office process, you could imagine gathering models from, let's say, your design team, or if you're already in the subcontractor fabrication phase, gather those models, plug those into Vico Office. In our case, we use our standard database to pull those quantities out and assign to unique line items that we'll use to populate the schedule tasks. However, in some cases, we don't have models available, or we only have some models available, which don't represent all of the scope, and we can represent those activities manually in that process. So if you happen to have a model available and a database, most of the work for quantity loading is actually done for you already. And in my experience, that's one of the, I think, primary reasons why resource loading, quantity loading schedules is so rare in the industry. It's just a lot of work. The good news is, if you've implemented Vico Office or are looking to implement Vico Office, most of that work is done for you as part of the basic Vico Office workflow. So it's simply a matter of taking all that line item data, quantity data, resource calculations, and assigning it to tasks to populate your schedule. In the absence of a model, we can use man-hours to resource load the schedule. It's a little bit less accurate, but it does give you some relative analytical comparisons from location to location. Now, I mentioned, well, I used a term, a phrase before to describe some of the data that we use as the building blocks in this system, and that's the uniform task list. For those of you who have watched some of the other scheduling webinars and or have talked to me personally or are generally involved with Vico, you've probably heard this phrase before. It's an important one to understand in this context, because it's like the second differing factor between a CPM schedule and a flow-line schedule. And that is, the first being the location breakdown structure, the second being how the tasks are represented. Now, in this case, I think I mentioned before, drywall, maybe there's 10 individual activities for 10 drywall locations on the job. Well, each one of those is going to have a unique ID. It's best not to worry about that too much. Usually I just take whatever unique ID and naming structure we have for those tasks and consolidate them into a generic kind of a uniform task representing that work. However, there are many locations in your typical CPM schedule that contain unique tasks as well. So part of the process for defining your task list is to what we call delocationize your schedule, which is to take all of the unique activities by location and consolidate those into a uniform task list wherever they exist in by location. And then after that, we go through the same process identifying unique activities. There's always going to be some kind of unique activities from location to location. And by identifying those, we can represent those in the correct place when we replicate the CPM schedule in Flowline. Now, I think one of the benefits of having a model involved in the process is you don't have to figure out where to put those unique tasks if they're being driven by modeled quantities. The model will tell you. So when you break the model into individual locations for planning and tracking your work according to your work breakdown structure, location breakdown structure, those quantities will already be represented in the proper locations in your schedule, in Schedule Planner. Also, quantities which may not have been identified in or represented in the CPM schedule are available, which gives you the opportunity to use or ignore those as needed. Oftentimes when I go through the process of replicating a CPM schedule, I identify 5 to 10 to 20 unique quantity items in the model which are not represented uniquely in the CPM schedule. That's not to say they're not accounted for in the durations of the schedule, but they're not identified uniquely, and so it becomes very difficult to track those items if they don't have that level of detail in the CPM schedule. And so this process allows us to identify any unique quantities which are currently not tracked and poses the question, do we need to track this quantity as a unique line item or not? And again, all of this is driven automatically by having a model available for you, which will tell you exactly all the pieces that are contained in that model and should be considered for representation in your schedule. As with any scheduling application, you generally don't distribute information by showing everything at all times all at once. So there's an amount of formatting that goes into organizing the data, creating custom views in your schedule, not only for, let's say, task groups or phases of the schedule, but since we're quantity and resource loading these tasks in the process, creating custom schedule views for individual subcontractors as well can give you a really good analytical tool for filtering down to, let's say, just your rebar subcontractor or just your drywall subcontractor, and being able to analyze the resource balance and the work continuity for those individual subtrades. Now, at the minimum, at least from Vico's side, when we provide this service to our clients, we will replicate exactly the individual or the unique groups that are represented in the P3 schedule, for example, or if it's a Microsoft project schedule. That way we have a direct comparison of scope from the CPM side to the Flowline side, which is as valuable for our own process and QA-ing the quality of the deliverable as it is for communicating it when we deliver that to our clients. Now, we're getting into the meat of it here, which is aligning the data to from the CPM schedule to the Flowline view. Now, what I'd like to do at this point is jump into a couple of files and take a look and kind of simulate the process for you, so you can get a feel for how it works. But basically, you could imagine that at this point we have loaded models into Vico Office for the scope that we're looking to analyze. We have linked those models and their takeoff items to a cost planner database, which we're using to pick apart the quantities and assign to individual activity line items that will be used to load the schedule. And then we've mapped those line items to the uniform task list that we have pulled from the CPM schedule. And at this point, we can move into the schedule planner environment and we're presented with a familiar scene. Let me go ahead and open up the file. For those of you familiar with the process, you'll probably recognize this. It's the default representation of activities coming out of the Vico Office environment. What you're seeing here in the flowline view is a superstructure schedule. It's really just steel erection and welding. And each activity is starting from day 1 and projecting from the bottom left to the top right corner of your flowline view according to the number of man hours that are assigned to it when we linked the activity quantity line items and resource line items in Vico Office to these activities. Now, what we have to consider next is work group count. So what kind of manpower do we have assigned to these activities? What is the installation sequence? And if you recall, we pulled that from the CPM schedule earlier by identifying the individual phases and the locations of those phases. And then we need to, of course, define the logic between all the activities. So that's where the logic export from the CPM schedule becomes an invaluable tool. Now, one of the characteristics of the flowline interface that becomes a very important factor in CPM schedule alignment is the fact that each of these tasks is quantity loaded by location. What that means and how that's represented in flowline is you're not going to get a nice straight line that represents a 5-day activity in every location. There's going to be some wiggle to that line. As you can see by this long blue line here representing the welding of structural steel. Now in this case, we were able to quantify the moment frame welds and the typical welds out of the model and represent those as resource requirements for this element. You can see that in some locations we've got a little bit different slope of production, and this is of course driven by the difference in quantities from location to location. Now, for a steel erection, I mean, this is pretty consistent. If you look at these, activity lines, they're basically straight, or as straight as you're ever going to see in a flowline schedule. When you start getting into interiors and exteriors and foundations, really too, the way that you've split out the location breakdown structure can yield very different production slopes by location. And the reason that we have these varying slopes is not only because of the difference of quantities in each location, but because the default action in the flowline representation is to assume a consistent crew size. So, the math is pretty straightforward. Quantity times productivity or consumption rate is going to yield your duration by location. So if we assume that the productivity rate is consistent, we have a consistent crew size, you're going to see a difference in the duration according to your quantities of work. And that's where we start to pick up the differences between the CPM style, a Gantt chart style schedule, and the quantity and resource loaded flowline method. And working through those to align the schedules is our next step. So let's say that we've taken those activities which have started from the first day of our schedule, and we've defined some logic between them and some general crew sizes in order to align with the overall duration of those schedules according to the CPM, according to the Gantt chart schedule. For example, our erect steel task has been defined as a total duration of 37 shifts. If we look at the individual durations for this activity, you can see that we were able to by forcing this overall duration to be 37 shifts to align with the overall duration of the Gantt chart schedule, Schedule Planner has suggested that we need a total number of 10 men on this activity to achieve that duration. And that's represented in our Durations tab here as a individual duration by location with an assumed work group count of 10. Now, it's not often in a Gantt chart schedule or a CPM schedule that you see durations that are widely varying or have decimal points in them. So if you wanted to go through the process at this point of exactly aligning the location duration with the duration that's specified in your CPM schedule, you could do that here in this Durations tab for the activity. So this is kind of an instructional video for those of you who are looking to try this at home. For example, if my duration for Level 1 Area A was not, or let's say is supposed to be 5 days instead of 2.4, according to the CPM schedule, I would modify my workgroup count to achieve the desired duration. If my next location was also expected to be 5 days, I would modify my workgroup count. But in this case, 5 days is projecting or calculating, 5 resources is calculating a 5.7-day duration. So if we wanted to exactly align with that 5-day duration that we had in the CPM schedule, we would have to add resources to achieve that. Now, what this means is if we're not following a location, or sorry, a quantity-based calculation for durations in the CPM schedule, we could end up with widely varying resource requirements from location to location within the flowline view. And this is one of the primary analysis that we provide as part of the CPM match service, is to, by aligning the durations exactly and the start dates and finish dates exactly with the CPM schedule, but also factoring in the quantities coming from the model and some assumed productivity rates or productivity rates given to you by the subcontractors, for example, we can determine what the approximate workgroup count or a number of resources or manpower required to achieve that duration by location. So let's take a look at this same schedule in a little bit more detail. After defining our logic and defining our or aligning our start and finish dates and durations by location for each of the activities, we end up with a match, a baseline match in between the CPM schedule and the flowline schedule, which, when you look at it in your Gantt chart view, doesn't look that bad. If we just sort to make these cascading, as we like to see in the Gantt chart view, difficult to tell if there are any problems. However, if we flip over to the flowline view of this exact same schedule, you can see that we may have some resource difficulties resulting from some stacking of locations in this schedule, namely the blue lines that we have here representing the welding of our structural steel, and the yellowish brown lines that are representing the deck welding. Now, the steel erection that's pretty straightforward most of the time. In this case, I wouldn't suggest to make any changes here. It's a nice straight line because there's no one ahead of there are no trades ahead of it up in the air, and so the steel erection really kind of sets the pace for this for this phase of the schedule. Now, there appears to be some differences in the overall production of the various activities in this schedule, as indicated by large open areas where there are no lines present. For example, down here towards the bottom in areas A and B, as you can see on the left-hand side of your screen, there are many locations for long periods of time, 2 to 3 to 4 weeks, that have no work at all planned. Now, this could be a result of, for those of you on the West Coast, this could be some OSHPD constraints saying that you can't do anything on that steel structure until you're poured out three floors above. However, it may also be caused simply by the logic that has been defined in the CPM schedule, which we aligned to. It may also be a result of what we call disparate location breakdown structures, which means sometimes in your CPM schedule you will, without thinking too much about it from a relationship perspective, from activity to activity, you may implement some constraints, let's say material constraints or logistical constraints in your schedule by implementing some different location sequences. For example, as you can see with the steel erection activity, if we just open that up and look at the details, the location sequence is set to go vertically, billboarding, if you will. We have level 1, 2, 3, 4, and roof, area A being performed before areas B, areas C, and D. So basically what we have going on for the steel erection is vertical installation across 4 locations that we have in the plan for this building. Now, if we look at the weld structural steel, that's occurring in a very different location breakdown, location sequence. It's difficult to pull from this view because so many of the lines are stacking. But if we look at the weld structural steel activity part, you can see that it's broken into individual kind of sub-sequences. So in this case, we have one crew that's working on level 1, A and B only. We have another crew that's working on level 2, A and B only. We have another crew that's working on the roof, A and B only. And each one of these lines that are broken are representing a unique duration for what we call a task part. Whereas the structural steel activity is a nice straight line with no breaks indicating continuous work, we have multiple or have planned for multiple activities, the same activity, but multiple locations active at the same time for your welding structural steel. Now, if we look at the resource graph for this representation of the CPM schedule, and let's show our steel welding resource. You can see that the way it's represented currently is to start with 4 men, then some days later jump up to 8, some days after that jump up to 11, then to 14, then to 16, and then to taper down, varying the crew size in some cases from just a matter of days or even from day to day, changing that crew size. On top of that, we have a maximum resource requirement for these steel welders set to be 16 resources. That's the high water mark. Now, that may be totally achievable. It may not be. the purpose of this analysis is to make the data transparent and available, and to be able to use that as a factor for analysis and for balancing the resources in your schedule. If we take a look at another resource for this steel erection phase, let's say not the steel welding labor, but the deck welding labor, we have a resource graph which looks like this, starting at 5 men, jumping up to 9, then to 12, then all the way up to 21. Now you can see the high water mark here, this peak of the resource graph. If you just carry that up into the flow line, you can see what's causing that. Each one of these lines in your flow line view is carrying a work group or a crew performing that line or performing that activity. And the stacking of activities that we have at this date or for these number of days is resulting in a very high resource requirement in the CPM plan. Now, oftentimes if you review this with a subcontractor and you ask them, is this how you intend on installing your work? They will respond no. It is not in their interest to vary their crew size from week to week. It causes some burden and adds risk to the schedule, not only for getting those guys as needed for each of the days and adding them and then releasing them as needed, but also it adds learning curve to the project or to the activity every time you add new guys to your crew. So the goal at this stage, after aligning the baseline schedule in Flowline, after representing exactly that CPM schedule in Flowline, what we want to do is review, provide an analysis, and use that as a way to kickstart an optimization workshop for optimizing, balancing this data. I'd like to show you an example of the report that was generated for this sample project. I'll zoom in a little bit so that we can have a little bit better resolution. So part of this analysis is to document the activities that we're looking at. And in this case, it's really just a few. It's just the structural steel erection phase, which is steel erection through steel welding, shakeout of your deck, and final deck welding as the scope relative to this analysis. If we look at the flowline view, we can document that and start to identify some of the concerns that we have with the resource management of this task. Now, in this case, it's probably not realistic to expect the subcontractors to change their crew size at every location. However, by aligning the start and stop dates and the durations with the CPM schedule by location, and factoring that against the actual amount of work in each location, which was very interesting in this case because we used the model to quantify the amount of welding, the amount of moment frame welding that we had in this building, based on the steel member size and the the internal moment frame of the superstructure. It resulted in very different quantities from location to location. And when we align those dates to the CPM schedule, schedule planner is telling us, okay, well, you're going to need some more guys here, or you're going to need less guys here in order to achieve this duration. Keep in mind that what we're doing with schedule planner, of course, is calculating, as accurately as possible the durations of the work, which is different from sometimes how tasks are represented in the CPM schedule as more of a window of time to complete your work. So we're making an assumption here, and we're kind of taking some license when we align the CPM schedule with the flowline view, that we're assuming that the subcontractor will balance their work within the time frame that they have by location as part of the baseline schedule. Now, that's not always the case. Sometimes they're given 10 days and they can complete their work in 6 days. That's kind of a different problem to mitigate, which I'm happy to discuss later. But at this point, let's continue through with the process for analysis. So we've identified several locations where the alignment of the start and stop dates for that activity has resulted in a variable crew size by location. In addition to crew variance, we've also identified several locations which appear to be stacked or planned to be in progress at the same time, which is having some negative representations in our resource graph relative to the not only the resource variance, but also the peak and valley resource counts. What we'd like to do as part of our suggestions for optimization is to eliminate the crew size variance and reduce starts and stops, of course, and promote continuous workflow, and also remove the stacking of trades that we were seeing, or the stacking of locations that we were seeing in the flowline view. In addition to that, general LBMS theory, flowline theory states that if you're going to be calculating an exact duration for what you think the schedule is going to, or what you think the task is going to require to be installed in a certain location, that may be affecting some of the float calculations that you had in your CPM schedule. And so part of our process for optimization as well is to suggest that we input some buffer or some time between activities where we perceive there to be a bottleneck or some handoff risk as a way to reintroduce the float back into the schedule in a designed way. Now, there's some additional information that was provided on this sample project. Was after reviewing this with the project team, we looked for ways to optimize the schedule, and actually were able to provide a couple of different scheduling scenarios to try and optimize the workflow. Now, one of the options was to take that stacked welding activity, represented by the blue lines here, and unify that as much as possible. Now, in this case, the pace of this phase was determined by the steel erection. And the reason that the welding was discontinuous and stacked in the CPM plan was because the duration was so much longer by location than the steel erection was. And if we were planning to make the welding a continuous line, as was the steel erection activity in flowline, it would really push out the end date for this phase. Imagine that this blue line here was a continuation of the line on the A and B locations that would have carried out at least 2 or 3 weeks, pushing the overall completion of this schedule phase. What we can do to try and mitigate that is not to employ an ASAP type of methodology like you would see in a CPM schedule, but to design a break where we can activate a second crew. And this is a representation of that theory. By defining 2 crews of 9 workers and splitting those between areas A and B and C and D, we minimize the overlap of and the total resource demand, but we also unify the crew size within each of the individual workflows. By splitting those locations into 2 crews, we can start the second crew earlier, which brings that end date for the phase closer to the originally planned date. And what we can see as a representation in the resource graph is a nice bell shape to that resource graph instead of peaks and valleys and significant numbers of crew size changes from week to week. Now, another option that we analyzed for that steel welding was the potential for one continuous crew, which of course would give us the best looking resource graph. However, in order to have a production rate that was in alignment with the steel erection and did not push the end date for this phase, it requires a resource count of 12 as compared to the resource count of 9 that we had defined previously for the 2-crew scenario. So this was another option that we provided as part of our analysis, was if we really wanted to streamline the welding, and in fact, if we simply couldn't get more than 12 people for this welding. Let's say it's kind of some specialty welds and there's not that many guys in the area who can do it. Reducing that peak resource count from 18 down to 12 would be a good decision. What it means is that you have to activate 12 guys early and try to keep them as continuous as possible through the job, which is represented here by this continuous resource graph for this activity.